Okay, my friends, either I showed you or I will show you the light experiments that Rod Warren and I did. Now, these people are shooting things head on and smashing them into little bits and digging through them to see what they can find. And you see the collision at the Large Hadron Collider. And they're looking for what they call these bosons. Well, here's what happens. It says, in the world of physics, nothing gets the blood flowing like the thought that a new particle has been discovered. Well, I got some new particles for you. For decades now, physicists have been hunting for evidence that the modern physics isn't right, which it isn't. But the smoking gun has remained elusive. In November, people started polishing a Nobel Prize for a group of physicists who seem to have found new boson. A new boson means a new force, which is even more exciting. Is that gun smoking yet? Now, they say sometimes the gun just smolders. This result has been cooking for quite some time, 5 years now. And so has our research with Rod and I. It's been a long time. The first experimental results date back to 2015. Essentially, scientists took some lithium, and we'll forget about this. They shot some protons, big chunks. Rod and I are working with light, so we don't have to go digging through them to find these little bits and particles. So I'm going to show you right now. Okay, I'm not going to do the whole thing here, but they say these are the big shots. The Royal Institution in London, 761,000 subscribers. This is the same stage that all of the big top guys, Faraday and everything, made all of their statements from. Now, this was the standard, quarks and leptons. This was supposed to be what existed. Well, they're finding all kinds of particles that they cannot account for. So out here she makes the statement that they can't deal with it. Here, let's see what she got there.
Lepton universality seems to be...
All right, here we go. That's right. It's called lepton universality, which means that they expect to see only these particles. Now they're seeing all kinds of things that they have no clue about. So here goes.
Electron stays, and lepton universality seems to be violated. Well, what that means is that there's something wrong with the standard model. We found the crack, finally, in our understanding of particle physics. There's absolutely no way that we can explain this observation with our current understanding. In fact, the only way we think we can explain what's going on is if there are new particles in the universe associated with new physics processes beyond those that we understand, and that these new particles are interfering with the B mesons as they decay and suppressing the decay to muons compared to electrons. Now, if that turns out to be the case, that will truly be momentous. Forget the Higgs. This will be the first sign of physics beyond the standard model, and it's what we've built the LHC to find out.
Well, here's their problem. This is what they can't understand, that everything is made of the tiniest particles. There is nothing bigger than than these. But once they hit a certain resonance frequency, and it's a vibrational frequency, and I'll show you that too. Spend some time with me now, because you get really time to learn the truth about this. They are thinking, well, there must be some new particle that we didn't know about that's this big. No, there isn't. There's a particle that big that's this many of these particles, these little bitty particles. That is the key. They're missing the whole big picture because they're looking for tiny things. Or they're looking for big things and they're missing the little things that make the big things. Got it? Okay, once again, my friends, the only place on planet Earth, or in the known universe that I know of, where you're going to find truth and the supporting evidence. Now, what is that? That is a pulsed red laser. These little particles are glowing because that pulsed red laser is a particle, and it owns a large magnetic region surrounding it, and I will explain it in a moment. Now, so it's basically a balloon coming through the air. Now, that balloon has a particle inside of it. Right? And the balloon surrounds that particle. Well, now the particle is escaping from the balloon and pulling outside of the balloon because it has to do that because it's being accelerated through a venturi. Look up venturi. It was used in the old cars. It's a carburation device. and it's two round pins. The light has to force those balloons to crush into each other's balloons, and then they shoot through here just exactly identical, no difference whatsoever, 100% totally the same as the nozzle of a hose. And the hose shoots the stuff out faster than it was coming in. And it pulls it away out of the hose and shoots it. It's like, this would be like the nozzle right here. It comes in and whew, it has to go, and there it goes. As it comes out, it's highly excited. When you're just coming through here at 1 mile an hour, it goes against you and it just rolls off you. When it comes out of here, you can actually, you put that into your eyeball, you're going to put your eyeball out. It gained a tremendous amount of energy. That's it. So we have accelerated a particle. So what did we start with? Red laser light. Light. Light is light. If you can say light is not light, well then the whole thing falls apart in the beginning. So light is light. This is red laser light coming from a red laser. That red laser. Simple as that. Red construction laser. Bip, bip, bip. It shoots out these pulses. And they will always look like this until they get accelerated. And then they do this. Simple as that. Rod Warren came up with this. And when I saw it, I said, Rod, I know what you got, brother. And then we worked together for a year or more. Now, coming out of this accelerator is Cherenkov white radiation. And at this point, electrons, which is light is made from electrons, and that I don't think there's any discussion about. It's obvious. They're the smallest particles, and light, as it travels, you don't see it. It's just so small you don't see it, but it controls space, and that's what glows. Now, and they're electrons, and they are also static, which collects in the air, strictly electrons. And they are also lightning, which collects in the ionosphere and then discharges to ground, strictly electrons. Everything else is matter, which is made up of electrons, only electrons. All right, let's go through the whole thing right now, my friends. That is a nucleus. And the bigger the nucleus, the higher up it gets in weight. And what does that mean? It means these particles in a nucleus are packed together. They are packed into a nucleus. Usually light is just floating around all by itself, static, just drifting around in the air, primarily attached to water molecules. Just an electron. All right? Just one of these. Right? And normally these are going to be floating around outside trying to get in. There's enough of them already in here to fill the quota to make whatever God designed that atom to be, and enough of these floating around that want to get in, trying like hell to get in there. Because the bigger this gets, the harder it pulls. All right? If it's small like hydrogen, it says, one out there, that's it. Helium, it says, well, if there's two out there, that's okay. Then it goes lithium, barium, all these ones, they get bigger, 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 until you get way down into lead and all these things. They got bazillions of extra electrons in the core, and there's so many in there that you're just pulling all kinds, and they just have that many floating around out here saying, I want to get in, I want to get in, I want to get in. Well, they can't get in because the quota's already full. So, these are nothing but particles, and they are not the gigantic protons and neutrons they talked about. And the calculation is that every proton that they used to say was a proton is approximately, and I believe this is about right, 1,837 electrons. It might be half of that, basically. Now, 1838 is a neutron, because it doesn't have that excess, or it doesn't have that missing particle to make it negative or positive. All right, because these are electrons. You add that extra electron back in, boop, it comes negative. They got half of that and half of the other ones. Now, that what this model does, and the Bohr model has been proven wrong, absolutely 100%. They know it's wrong. There's no question about it. They're just trying to look for new particles. Well, they don't have to look for new particles because these make the particles. You can make any particle you want now. That's what they're looking for, is these exotic particles. Oh, we can never explain these. Of course you can. These make them. These make them. And the reason they can make them is because instead of going from one more proton to go to here, you could add another 20,000 because you got neutrons and protons adding between these things. So you got thousands and thousands of particles instead of one or two. All right, so let's take a look at something else. Okay, this is my universe. This is light. And there is one tiny little particle in there, owns a big region, like I said before. All of these are starting to get concussed because everything starts to be perturbed. Then it gains its speed as it approaches the Venturi. So there's no question whatsoever light can speed up. Absolutely none. Now, that's a single slit, so these are not interference patterns, those are repulsion patterns. Coming out of here, I am going to show you that the white and the black separate. In a second, I'm going to show you what light literally looks like, and they are electrons, and they can separate from each other in here. That's charge separation. I can show it and prove it. And then here they start to recombine, but they're still they do have that interference pattern. That's repulsion. They want to stay away from each other, so they make these stripes. I'll stay in my line, you stay in your line, and they follow each other. Stay your side, you stay your side, and that's how you get this. And light is also a spinning particle, not a wave. It has nothing to do with a wave. It's a particle that is in, hold on, just like this. I know I showed this a zillion times. People get mad. You keep saying it's showing the same thing. Well, I'm not just showing it for you, my friend. I'm showing it for everybody. And nobody is passing this information on. You see, I'm not getting enough hits. I'm not getting anybody's putting it out to anybody that's taking any interest in it that I can see. Anyway, this is what happens. And I will show this. I've got pictures of the whole thing. Rod did unbelievable work. That's a wave. That's a blue. That's, as it starts to go slower, you get into the yellows and greens, and then you get into the red, which is long. And I could show that too. All right, so, and then, because they're spinning so fast, and this is a dipole, has a plus and a minus on the same little bit, it creates these patterned fields. It's a plus and minus, and it's spinning just like this. And it's spinning so fast coming out of here. That's coming out of here. Zip like this. Zip. And it's so fast it's going plus minus, plus minus, plus minus, plus minus, and creating these Higgs fields. All right. Now, one of these particles came out of here just white. It looked just like this. It was right up here, and it looked just like that. And you could see it was trailing off, and it was spinning backwards, and then that particle did this. It hit one of these other ones and created whatever that is. That's the particle. And it had some kind of structure to it, and now it seems to be making its own ghost structure and leading something off. I have no idea. And that's something that I don't think Rod can recreate. I'm not even sure he can recreate any of this stuff anymore. This has been years, and anyway, this is what well, I know we can recreate it. That's not the key. It's just it's a lot of work. I don't know if he's going to want to do it. Let me go that route. Now, this was over a year, and we worked every day a lot. I'm compulsive. I have to admit it. I can't help myself. When I get onto something, I cannot stop until I feel I'm done, or somebody else is done with me. And Rod stuck with me right to the end. He's a tough guy, tough guy. Anyway, see the black and white and black and white? I think that's an electron here, and that's an electron here. Same thing here, electron here, electron here. And I can see them, they got spikes coming out of them. You see it? Now this is as they slow down and they start to recapture their black parts. Now, so we have seen it up here, we saw it accelerate, absolutely no question. Now, here we see it decelerate, which means it's slowing down. Here it's going fast, spinning to the right, as I said before, just like this, zip, 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 which means it would drift to the left, click, 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 click. And you can see it's expanded and it's contracting up here, which means it is slowing down, quite obviously. No question whatsoever. And if you can't see that, I cannot help you. This is my problem. When somebody doesn't want to see something, they say, well, I don't see that. Well, I see it. All right, here's the Venturi. Remember it came through this way and accelerated, pulled away from its bubble? Here they are here. Now, why do we have this just totally white? And if you look extremely carefully, you'll see little black dots. Let me home in on here so you can see this a little better. Now, what do we see, my friends? We see Cherenkov radiation. All right, that's that glowy white, explosive, interactive, highly energetic glow. Now, what about the black ones? They just walked away. They just said, look, you guys do what you're going to do. We'll meet you over here. You see them? I can't account for this. I can see it. I know what's happening. So what we have is everything is made of these particles. But these particles are a plus and a minus, a black and a white together. And when they go flying through, because they're as a plus and a minus, they spin. They make a right-hand spin. It's called the right-hand rule, and we're going to look at salt vibrating, which is going to show you how these things build, because they are resonant frequency. There's going to be some kind of interaction in this glob, and then it'll reach a shaky, and then it'll stop, because everybody has found their position in this blob. So it might be like this, starting like this, and all of a sudden, blip, it comes together in a nice round blob, or it might be a hexagon. I don't know what it's going to be, but it's going to be it's probably going to be some crystalline type of structure, but it'll be some globular structure that's stable and can sort of exist in that accumulation of particles without a big issue. And then other ones will collect around them because they want to penetrate to get into the positive. Now, I'm going to show you that, and then I'm going to show you how electron flood particle works. Okay, this is called the Amazing Resonance Experiment from Bruspup, and this goes back to 2013, and everybody's hero, every researcher, is Nikola Tesla, and let's listen to what it has to say, because everything, all energy is frequency and vibration. Here goes. And that's the entire universe. And they are only made out of particles. Each one of those is an electron, and they have a positive and a negative. And we are now going to see them in their vibration until they set up a nice, even shakiness. They're going to put salt on it. Salt is a positive negative, NaCl. Both sides of the periodic chart, NaCl. Now, here goes. Now they're going to do frequencies, tone generate, which is nothing more than vibrating molecules in the air, which are nothing more than electrons, so they make electrical vibrations. That, my friend, would be hydrogen. And then it goes up to helium, which would be a 2, and then it goes into the rule of 8. And this would be your central core orbital, and here's your rule of 8 surrounding it. And it gets more and more complex. These are the frequencies. So they're shaking, and so they're higher, they shake, the more complex it gets. This is electron flood theory, only these are electrons. See, there's your rule of 8 again. And these, all of these outside ones are trying to penetrate and get into the central core, because this is where the more and more and more and more are building here. All right, that determines what elements you have. And then the bigger this gets, it will try to collect more and more and more electrons around it, because they want to get in, because there's more and more and more pull. And he just keeps getting more and more exotic. And you'll see they're regions. They may look like they might look like stripes, but they're not. They're regions. And they control and they push these other things away from them, because they have the magnetic wherewithal to control a circular region. But when you're imposing on that region, it might flatten out, it might just, but you're always going to see a little bit of a curve, which is where the particle resides, inside that curve somewhat. But the curve's being inflected by this one and this one, this one. This is elegant stuff. And the higher frequency you get, the more complicated you get, until you get up in gold and lead and all these things. Now, as you want to think about this, the higher you get up with these frequencies, let's just stop it right here. An atomic bomb is nothing more than getting up to so high of concentration of particles and then crushing them together with a whole batch of other ones that are so extremely high in particle density that they just explode and chunks go everywhere. That's what a nuclear bomb is. And pretty much the radiation comes apart, all of these go flying apart by themselves, or one or two or three of them, that type of thing. And they're going so fast because they just slam into you. Usually it's going to be a few of these, like a chunk like this. You slap you in the face and you're dead. That's the way nuclear structure works. And again, they now claim, and they, obviously it doesn't work. They know it doesn't work, the Bohr model. And Einstein's wrong about light being a particle, not being a particle, being a wave or a particle, and not either one, or I don't know what he ended up deciding, but it was wrong about everything. Let's go with that. And therefore, we have no clue about gravity, and we don't have any idea whatsoever where we are in space. None, zero, because any of these places could be sending us particles that aren't going even the speed that we're expecting them. There's certainly no redshift that accounts for everything speeding away from us faster than the speed of light's supposed to be able to go. So wherever these particles are coming from, we really don't know how fast they are coming at us or how much they're slowing down. So we don't know where the Pleiades is. We have no idea. I know the Earth is round, but after that, I'm about done with what they've been telling us. They've been laughing at everybody for questioning anything. And as soon as I started questioning it, I tried to question everything. And then when I questioned everything, I found that everything was wrong. So, I've been having people attack me. Oh, you think you're just a big shot. You're doing this and that. Well, attack me. I don't care. Because I didn't want to get into this in the first place. I'm here now, and I am not walking away until this gets seen and heard. And then I'm going to sit back and watch. Gabish? All right, this is absolutely amazing. Look at this, 3 minutes, 4 minutes now. I'm going to draw my interpretation of what the nucleus would look like, and I get this from Demeter, and it's supposed to, I don't know what it is, to be perfectly honest with you. I'm not going to even comment on it, but this virtually is what the nucleus would look like. And these are the positive and negative of each particle. And they're going to oppose each other in such a way that it's going to be elegant, just like that. So the nucleus will set up a region until it's just perfect, and then they'll lock in, just like I showed you a minute ago. Now, what's going to happen is there's going to be a ton of attractiveness in here, which will be the positiveness that wants the electrons to come, and then there are going to be a ton of electrons that want to come in, but these are going to say, no, we are stable now, you have to stay out here, and you can stay, one will stay here, one will stay over here, one will stay over here, one will stay over here, and like that, and they'll make those circular orbitals. But they'll be pushing each other away from each other until they have really a cloud. But there's only going to be a few here and there. It's not. This is where it's packed in, and this is where matter takes on weight, because the Earth wants to attract electrons. So the more electrons that are in the more condensed space, the heavier it is, the harder it hits Earth. That's gravity. It wants electrons to hit Earth. Static electricity is only electrons, right to Earth, just like that, violently. Lightning, only electrons. There's no matter. They're not all clouded together like these. These hit the ground because they're in a chunk. Electrons that are free electrons is electricity. You take electricity out of a wire, you put it, and you always have it to ground. It's supposed to go to ground because ground will accept it, and you won't get electrocuted. That's why you're supposed to have everything grounded. So it'll go zzz, right to ground, but you'll see them go zzz, you see smoke coming up and everything, because they're fighting, those electrons are fighting into other clumps like this. They say, we don't want you. And he said, I don't care, I'm coming. And the Earth takes it, and then it dissipates through the Earth, because that is gravity. Earth sucks electrons. And it does it because it's a generator. The Earth is spinning its electrons within the cloud of electrons that is our atmosphere, our ionosphere, our magnetosphere, our outside source of electrons. Thousands of degrees out there on the surface of the Earth, 80, 90 degrees. Same thing with the sun. The sun is only just bigger, and instead of having its atmosphere just stirred up and getting hotter and colder, it gets these magnetic loops. Because it's so big, it's and all of this stuff is, and it's millions of degrees out here and 6,000 on the surface. So it has nothing, zero, to do with fusion. All of these things were guesses that were all wrong, and now it's time to look at them again. If I'm wrong, I'm wrong, but I'm not wrong. So now, anyway, I was going to show this. I was going to draw a whole bunch of things, but what will happen is the central interior core, all the positives will come together, because they can go together without hurting each other. They will accept that, and then all the negatives will come to the outside. They'll be. I can show you this in a toy. Watch. It's quantum mechanics. You're going to watch quantum mechanics with a toy. Now, what he's going to do is he's going to take and put a central core, positive, and then he's got the negatives surrounding it. This is called electron flood. So now, the positiveness is in the center, the negativeness is around it, and another negative is going to come in and try to attach. Boom, and it can't get there, because the negativeness surrounding it, which I showed you before in that ball, is going to push it away. So say, no, we're all set. You're going to have to stay there. Now, it will shake around. They will jiggle around as you push electricity into them, heat them up, because that's all you're doing is pushing more electrons in when you heat something up. You're flooding electrons into it, and they can't take it because there's already extra electrons in everything. There's ether. It's called ether. Now, that was light. As soon as it drifts away, it's called light. Now, within everything, within every rock, or everything there is made out of molecules. Those molecules are those balls of particles. They're like this. All right? And then they're going to be surrounded by a certain number of electrons. I think I showed that, I hope, well enough for you to understand. What else is in here? There's a ton of extra little ones that are just floating around in here that are not attached to anybody in particular. Those are, in the air, they're called ether, or we would call them static electricity. And in this, it's the same thing, only they're more confined. In the air, they're just floating around, and you can walk through it, and if you're a moisture thing in the air, you have a more water molecules on you. Water is very polar, H2O. It's got an H side and it's got an O side. H side is the positive side. The O takes on the extra electrons. It becomes the negative side, so it's a highly polar molecule. So you're going to take on an extra electron here, one over here. That's what it does. So water is the primary holder of electrons in the air. Well, there's also moisture in everything else, but it doesn't have to be moisture in here. These can hold on to the extra electrons with all kinds of different chemistry. And that's why you have batteries. That's why a battery holds on to a ton of extra electrons. And anyway, I keep getting off on these crazy things. But this is the tractor beam magnets, and it'll surround a whole bunch of them. Just got delivered my kefir, milk kefir. I know I go in all different directions here, but that's just my style. I can't help it. There is so many directions to go. Anyway, this is what sets up your quantum mechanics. I suppose that's about enough of that. Now, we're going to look at what Hubble has to say against what I have to say. Now, this is work I did with Rod Warren, and this is standard red light from a laser pulsed. This is as it accelerates. So we know that light can accelerate. Absolutely no question whatsoever it can accelerate. And it is a particle, no question whatsoever. And it accelerates through a venturi exactly like gas did in a carbureted engine. And what comes out is the atomized particles, which are so concussed with each other that they're involved in each other's regions. The black ones surround it, and I will show you that in a minute. These are not interference patterns, those are repulsion patterns set up against each other's flow. So they create what they call interference patterns. This is single slits, not a double slit, so it has nothing to do with interference. These are what they call Higgs fields. This is a new particle nobody's ever seen. It's spun backwards through the accelerator. Could be antimatter, no clue. That is what appears to be the light. This shows absolutely without any question whatsoever that light can slow down. It's faster here and it's compressed here. There's no doubt whatsoever. Zero. So it's time to look at this stuff with a little bit more concern than just, oh, we don't want to see it. All right, here's my issue. Hubble took Einstein at his word that light cannot slow down and it cannot speed up. Therefore, everything has to be moving at a certain speed. Well, we're seeing it looks like it's slowing down. He says, no, it can't slow down, so it must be moving away from us. Totally nonsense. I can tell you right now, and I can prove to you, light can speed up. This is red laser light. Light is light. I don't care how you cut it. If this is light, then it can speed up, because here it is going through a venturi. Case is closed. The particle is pulling itself away from its wave nature. And when I say wave nature, this is a particle, and that particle controls a region like gigantic. That's why you see this big wave coming through there. It's like a balloon, and the particle is in the center, and it controls a magnetic region around it. Well, once it approaches this venturi, which forces everything to come together, all these balloons are coming together, exploding like bombs. But only half of them explodes, the white part. There's a black part here that doesn't explode. All right, now let's just take a quick look at this, and then I'm going to show you why Hubble and Einstein, and they're all wrong. Here's the Higgs fields that CERN talks about coming out of the venturi, out of the accelerator, coming this way. They smash things together and then look for these coming apart in little bitty pieces. We're starting with the smallest pieces, and we're seeing what they do when they accelerate. And here's one that came backwards through. This a picture identical to this. There was one white one right up in here. And that's the white one right there. And did this, and then it did that, whatever that is. It looks like it's a... Now, these here are what appear to be the actual light particles, and I'll show how they can separate the black from the white, and then they come back together. This unquestionably demonstrates that the light is expanded here and is crushing here. It's slowing down. So this was a red pulse laser, a cheap construction laser, nothing special, and these were two metal drums forcing that light to go through there. $50 worth of stuff. Now, let's see what happens next. All right, here is that acceleration process. When they concuss and explode, I showed you you had a black and a white back to back. I believe they're two electrons back to back, and that's what these are. When they crash, they separate. The blacks come away from the white particles. The white particles are explosive. The black ones just sort of dribble away. They come back here, and they reassociate back here to the white ones. All right, that's charge separation. Electrons make up everything there is in the universe. That's all there is electrons, and that's why the Bohr model, now they agree it doesn't work. It's wrong, totally wrong, but they're looking for some exotic particle. No, they're all made of the same particles, and that makes it work. Okay, so how wrong are Einstein and Hubble? Well, they're wrong enough to put us into Never Never Land. We have absolutely no idea where we are in the universe now. If light can speed up and slow down, everything has been decided. All of these things are this distance away because of the shift of the light. Well, the light might be coming faster, it might be coming slower, it might be coming through more dense stuff than you know, you can see it's thicker and thinner. And we are scrubbing through the Milky Way, and our arms are ripping backwards because there's nothing but particles everywhere in the universe. It's called dark energy and dark matter. And because we are scrubbing through this stuff, spinning at the same time, our electrons are scrubbing through these electrons, creating a generator, creates electricity through our poles, up through the north and around. That's our magnetosphere, and it is gravity. All electrons are sucked to Earth, and Earth sucks them through. Earth is the ground. It will accept all electrons beyond anybody else because they're sucking through. And if you take static, it burns its way into whatever it discharges in. All right, so at this point, redshift is absolutely meaningless because light, it can go faster, it can go slower. I believe it's related to where it is emitted from, how hard it can leave that source. Is it being thrown away hard, or is it gently being thrown away? That's what I want to know. And I also want to see what are the sizes of these particles. Well, let me show you something. Okay, basically all the light shots that you saw, Rod Warren did those. I worked with him, and I have all the same stuff, but he was just so good at it now. And then we put it out to other people, and Fabien Brulé, I believe he's over in France, he did this where he put red and green at the same time through the accelerator, and he can see some red particles that were diffused out of there. I don't know what exactly happened there, but you can see that the green and the red come through very similarly, and then the red's done, and the green shows back up again. I don't know exactly what that's about. And then you can see the green sort of tumbling away as it interacts with the red. Very strange effects. And then, of course, you got the same black and white, only, of course, you know, they're green and black and so forth. And Rod had, you know, that's the shape of these particles. That's what they are. You know, and here's Rod again coming through the accelerator, and here's the particles. All right, I'm going to show you even a better shot. All right, there's the green electron. They're the same as the red ones, identical, only it's green. Now, is it this and this, like a positive, you know, a upside down electron, and, you know, that type of thing? Because you can see there's something concussing out here, and these are coming forward. So they're bashing into something here, or here, or whatever. But these are spikes coming up. Now the first, they only show up twice, and then apparently they lose that look because they're really bright, and then they boop boop, and then they go into these little white, and well, I can show it to you on the red one because it's much easier to see, and I will. I really don't know how to interpret this exactly, whether it's a box of electrons, two here, and then two behind and two behind, or are they up on top and below, or is that just one electron? Well, it's light, so it's got to be. Well, I could see it's balanced. So if I saw this, I'd say that's like a dumbbell floating through. But this is a balanced thing. Now let's I know I'm mumbling on here, but this is pretty new stuff. So it requires some mumbling. All right, here's the red electrons. And it's just a different colored light, that's all. Now, they look exactly the same. Now, this is coming through the accelerator, and they come out with this kind of blurry looking at first. This is like really confused. Then they come out a little bit blurry, and then they resolve to this, and then they go back to here. See, they got white, black, white. Here, they do this, and then they got black, white, black. I don't know. It's very strange, but here's what you see, and it seems to be only two waves. And the first one, you see the spikes coming up. And then the second one seems to start to like flatten out a little bit. In other words, this one here is boom, and it's like this and sort of doing this thing. I don't know. And by the time it hits here, it's sort of coming down, and then the next thing you know, it flattens right out to this over here. See it? It was here, and then it flattens right out to that, and then it just carries on with the flat stage, and then it just, I don't know what it does after that. It just bashes into something. I don't know. But these appear to be the particles. This is right after the accelerator. And they come out of it. I have so many shots. I could go on and on for hours here, and I probably have. Anyway, it's time to look at this stuff a little differently. I don't know. I just keep rambling on and rambling on. People getting upset at me. They say, "Oh, you keep running your mouth. Well, I guess I'm just going to keep doing it until somebody pays attention, and they say, you're an idiot, or they say, well, we're going to look at it. And that's all I wanted to say is look at it. Because you can't not see this if it's looked at, in my opinion. And again, I could be an idiot. Prove it to me, I'll wear a sign saying I am an idiot.